Idaho National Laboratory came on when we were just an IP. My product had won the statewide contest, so they offered us to help us with the testing. And we just finished our tests for the amperage and for the voltage breakout. The amperage test was performed a number of times. We have a trend at this point to see what our devices will do for future use.
Today we measured 3 different points of temperature, one on the outside of the insulation, center of the connector, one drilled through the connector down to the copper insert, where we measured the internal temperature, and then one of just the cable directly outside of it. In the case of the 4-aught we were testing, it was 360 amps. And once it's at 360 amps, the connector will start to heat up. Once it finally levels off for a while and maintains within 3.6 degrees Fahrenheit, that's when you can consider it to have reached a stable temperature. And then whatever the maximums are at that point are what UL compares to their standard.
The voltage test, we were able to test our product and exceed what the UL test would be by a factor of 5 or 6 times greater than what the UL would perform on our products.
I mean, the standard UL test is to load it up to 3,400 volts and it has to hold it for 1 minute. And so, I mean, our connectors blow through that. That's nothing for them. And so then after that, just for fun, because we have the equipment to do it, we keep adding more and more voltage till eventually it pops out of there. And it usually goes at least 6 times what UL requires.
The products that we tested today were strictly prototypes. These were built on an SLA printer type machine, and they still passed all of the tests to be able to be qualified under the UL testing. The products that we will be using for our production line, these will be plastics that have already been pre-approved by UL. So we would be looking at a much stronger product with the materials that we would be using for the production run.
My name is Chris Rogers, and I've been in the trade for about 13 years. When we heard about the Melni connector, it was something that sparked our interest. The current process that we have for fixing secondary faults on a line is a pretty lengthy process. The one thing about the hand crimping tools is that you need quite a bit of room to crimp. And when you dig down, if you have a foot space, it's very restricting. Once we have the tools prepared, once we've stripped the conductors back, find the fault, then actually getting the right size of crimps for the wire itself is always a big concern in the field. It takes quite a bit of time. When we did the test on the Melni connector versus the older process, the crimp splice, we did them side by side, and I did a crimp splice to begin with. And then the first time we used the Melni connector, I was shown kind of the process beforehand, and it was extremely easier. And the length of time was cut, in half by far. To 1, I would use a Melni connector over a crimp splice any day. It is incredibly simple.